ANSYS Simulation, Lecture 17, Explicit Dynamics. First of all, we drag explicit dynamics onto geometry. This module is for high velocity impact and for those cases where deformation is very large, plastic deformation is very large. And first of all, we will edit material, and I'll choose in the data library the explicit dynamic materials, and I'll choose aluminum alloy 6061 aluminum, and also steel 4340 steel. And close the library. We have two materials from explicit dynamic. This is aluminum alloy 6061, and this is nickel chrome moly steel. The Japanese JIS standard is SNCM 439. So we go back to project and edit the case. And explicit dynamics is a very powerful procedure, and its kernel is Dyna's kernel. So first of all, we choose material. For the anvil, we choose steel 4340, and for the projectile, we choose aluminum alloy 6061. And for connections, we will delete the contact and leave the body interactions as frictionless interaction, and we'll build a mesh. And this is the step 3. Step 4, boundary conditions. And for the ANSYS setting, I'll set 0.01 second, and this is the time for impact. This is a high velocity impact. So I'll add an initial condition for loading. Insert a velocity on the projectile, and the direction will be along this direction, the direction of the projectile, the velocity. And then the magnitude will be, for example, 300 meters per second. And make sure that the unit is correct, 300 meters per second. So you can see the arrow is downwards. So this is the loading, the velocity. And we define it in initial condition, insert a velocity. And this is the constraint. And the time of solution will be 0.01 seconds. So we will have deformation and stress and solve. And I'll stop recording because it will take a little bit of time. It took about 25 minutes already, and it is finished. So we can take a look at the impact event, and this is the stress. We can make it smoother and slower. You can see that the stress wave is undulating on the projectile. And this explicit dynamic module is very powerful for those high velocity impact problems and also very large plastic deformation problems. And you can also reverse the material. For example, you can reverse the material so that this part, the base will be soft material, and the projectile become a rigid material, and you can run again, so you can see that there is a plastic deformation occur on the anvil or the base. And also you can have user-defined result, for example v vector, velocity vector, and you can solve for the velocity vector, and it will give you the arrows for velocity in all the directions. And this is the lecture 17 for ANSYS Explicit Dynamics module.